Hello again. This is Handbook 3, the 2-sample t-test. So in some situations you might have two groups of data and you want to test if there's a significant differences between them. In this case you can use something called a 2-sample t-test. The following example you use a dataset called Flock CSV. This can be found on the Moodle page, but I've saved it directly to my desktop. So in order to load the dataset, just as we've shown before, go to Data, Import Data. It's a CSV, so you want a text file there. We'll call the dataset whatever we want. In this case, I'm going to stick to the title Flock. Ensure that you've selected commas here and click OK. It'll now allow you to navigate to wherever it is. I've saved mine on my desktop. So if we scroll all the way down, Flock should be at the bottom. Remember, you can get this from the undergraduate Science and the Environment Moodle page. So click Open. If everything's gone well, it should be blue at the bottom here. So our dataset has 24 rows and 2 columns. It's always good to check again. So View Dataset, OK. So we've got a continuous variable here with lots of data, and then we've got a grouping variable here, which is species, in this case A or B. One of the assumptions of a 2-sample t-test is that the data is normally distributed and there is equal variance between them. And these are two things that we have to test. In one of the previous podcasts, we've looked at normality testing. Easiest way to do this is to go to Statistics, Summaries, Shapiro-Wilks Test of Normality, highlight the variable you're interested in, and click OK. Again, the bits that we're interested in have come in the output file here, at the output screen. So we've got our test statistic value, and we've got our p-value. Remember, the value needs to be above 0.05 to be normally distributed. In this case, our data looks normal to me. It's well above 0.05. So that's one of the first assumptions that's been met. The second is to test for equal variance. In order to do this, we need to go back to statistics. Then we go down to variances, and we click on Bartlett's test. This will allow us to select our response variable, which is flock size, and will allow us to select our grouping variable species. So this test is looking to see if the variability between the two groups is similar. So in order to run the test, we click OK, and the results of our test are down here. And again, it's testing to see if our variability between the two groups is significantly different. Produces the test statistic, which is the Bartlett's k-squared value, produces a degrees of freedom, which is the number of groups minus 1, or n minus 1, and it gives you the p-value. And again, we want to see if this is above or below 0.05. In this case, it's well above, so there's no significant difference in the variance between them. If we wanted to write that in a report format, you may write something similar to this. You may say there is no significant difference in the variance found between flock size between the two different species, and then in brackets you'd put the test statistic, which is your Bartlett's k-squared value, you put your degrees of freedom, and you put your p-value. So now that we know both of the assumptions for a t-test are met, we can actually perform the t-test. In order to perform the t-test, we go to Statistics, we go down to Means, and we select Independent Sample t-test. We now select the grouping variable, in this case select species because we want to compare between species A and species B, and then you can select the response variable, which in this case was the flock size. When you're happy with that, click OK, and the results are down here. Okay, so there's a few pieces of information here. Don't be overwhelmed. First is the t-value. That's actually your test statistic again. Your degrees of freedom, and your p-value. And the p-value is what we're really interested in. So looking at the p-value here, you can see that it's above 0.05, so therefore you'd say there is no significant difference in group sizes or flock sizes between the two different species. One of the other outputs here looks at the actual means for each of the different species. So we've got 27.27 for species A and 32.31 for species B. So you can see they're very, very similar. You may write this in a report as saying there's an output just written some output just up here and say there is no significant difference in the mean flock size between the two species. In brackets then you put the t-value, the degrees of freedom and the p-value, and then you may explain a little bit more, give a bit more detail. You could say however species B showed a higher average flock size than species A, and then in brackets you can put the mean values for the two species. So you can emphasize there is a difference, but in this case it was found not to be significant. In a situation where you do find a significant difference, you may wish to display your data. And the easiest way to do that when you're comparing two means is to produce a box plot. So if you go to graphs, you go to box plot, pick your continuous variable, which in this example was flock size, and then ask it to plot by groups, in this case species. With all graphs gives you an options label, so we can label our axes. I'm going to call my X label species, so species A, species B. I'm going to call my Y axis flock size. I'm going to call my graph, give my graph a title, so this one's going to be figure 2, flock size. Once you're happy with that, and you're happy with the labels, just click OK, and we get a box plot here. You can see there's quite a lot of overlap between the two species, and they show very similar median values, so that's why it's not finding a significant difference. So if you wanted to insert something like that into your report, it would help visually describe the data. And that's a two-sample t-test. Thank you very much.